Hey. The lesson will be posted online if you need to watch it again. Here we go. Do you all actually watch this?
Yeah, I do my homework. No, like the homework.
Really creepy. Okay.
I feel more concentrated.
Concentrate. Okay. Today's topic of discussion is translations. This is not a new topic. This is why I want to do some of this with you in class, so that you can have the rest of the period kind of just ask questions if needed, and I'll walk around. Translations and reflections. This is from the 6th grade, so it's not hard. Okay. So let's do some of these together, and I'll let you do your own thing. A translation. When you translate something.
Slide in there.
Well, the translations in general. Like, when you say translations, what are you thinking?
Follow me.
Yes, Jill.
Whenever you translate something like someone speaking Espanol,
Like language, right? Translations. Okay. So you're saying Spanish and English and vice versa, right? So essentially, it's the same meaning, right? You're just kind of switching places. It's the same thing in math. In translations in pre-algebra, translations, the SL in translation is a slide.
No,
Calm down. It's a slide. The shape and the size does not change. The shape and the size does not change. No. The shape and the size does not change, okay? You're not making anything bigger or anything smaller. So all you're doing is you're just moving the position around, the shape of where it's located on the grid. That's all you're doing, okay? This should be familiar, but just in case you're not familiar, we're going to go over it. Just a few of these. Number 1, it says draw the image of the figure after the indicated translation. So again, the shape does not change and the size does not change, only where it's located. It usually tells you the direction. For example, in number 1, it says 2 units left and 3 up. Okay, so what does that actually mean?
you go to the left.
No, think about it. What, but more specific, like what is moving?
It's like
The what? I heard it. The point, right? The shape is moving, but more specifically, the point. Good. Thank you, Melanie. So the point is moving. So this is if these are the original points, you're just moving the points to create the shape. So it tells you 2 to the left and 3 up. 2 to the left and 3 up. Okay. If you forget what left and right is, because I do all the time. Left hand makes an L. Left hand. Left hand, left hand. I seriously drive in circles sometimes. I forget where left is. Not kidding. So then I'll drive and I'll be like, steering wheel, like, okay, that's left. True story. Okay. 2 to the left, 3 up. Dot. Move this dot. 2 to the left and 3 up. 2 to the left and 3 up. The shape is the same. The size is the same. The location is different. That's all a translation is.
what? Wait, hold on.
You okay?
No.
Tourette's or something. Okay. And number 2. Number 2. I'm going to do number 2. 4 to the right and 1 up. So I like to rewrite the directions 4 to the right and 1 up. So take the dots here. I like to kind of highlight those are called vertices or corners. These little dots are vertices. These are points. 4 to the right. 1, 2, 3, 4. Go up 1. Put a dot. 4 to the right. 1, 2, 3, 4. Up 1. 4, 1, 2, 3, 4. Up 1. 1, 2, 3, 4. Up 1. 1. The shape is the same. Just the position changes. Dylan, stop bothering her. Questions? No? All right. Let me move down here a little bit. Now, what's different about let's say number 5. What's the difference there? There's no shape. And what else is not given to you? What else do you have to find?
Where the dots go.
Where the points, where the dots, where the vertices located, right? So again, remember to keep in mind that if you go back to think about how the coordinate plane is situated, remember that it makes a C, positive, positive, negative, positive, negative, negative, positive, negative. Okay? The coordinate plane is something that people use all the time. That's how cities, if you're an architect, if you're a city planner, you have to plan cities out using coordinate planes. Bus routes, when they do coordinate planes, GPS from a phone, right? That's a coordinate plane too. They can always locate where you are using the points.
Remember the thing, where's my
Yeah, I actually lost my phone. Not kidding. I lost my phone at Subway. I left it on the table. I didn't realize I walked out, and I came back here to work. And then I was like, "Where's my phone?" And then I went back, but I thankfully didn't. I was able to grab another iPhone, and I logged in, and it was still there.
Was it your iPhone?
It was my phone. It was still there. So what happened was the coordinate planes. It pinged up on my phone, and it showed exactly where it was located.
You got very lucky.
I was very lucky.
I know, I left my
But guess what? You can go to jail because that can go to your house. Hello, you can't turn that stuff off. Yeah, you found. Yeah, okay. Okay.
Ow!
Shh.
I thought that myself.
Okay. Here we go. Letter A, number 5. Shh. Letter A, vertice letter A. -3, -1. -1, 2, 3, down 1. Letter A. B, -4, -4. 1, 2, 3, 4, down 1, 2, 3, 4. B. C, -1, -2. Remember, it makes a triangle. How many sides to a triangle? 3. Okay. And then the directions, Merle, it tells you to move 4 right and 1 up. So graph the original. This is the old one. Where's the new one located? Well, move everything to the right. 1, 2, 3, 4, up 1. 1, 2, 3, 4, up 1. 1, 2, 3, 4, up 1. I want to play Battleship now. That's a good game.
I've never played.
Really?
I don't know how to play.
I might have to bring my Battleship up here. This is it's a coordinate planes.
You actually have it.
Yes.
You found it.
Because that's a math game. I mean, it's all
I
math.
can beat you at croquet.
I'm sure. All right. Any questions on the rest of the front page? So you know your tutor, right?
This is our homework.
All right. On the back page. The back page. We have about 20 minutes left, so we can get a lot of it done. On the back page, where it says reflection. When you look yourself in the mirror, what do you see?
An ugly person.
You got problems there. You see your reflection. Thank you. You see a reflection of yourself, right? Just like when you look in the mirror. Where's my mirror? Mirror here. Okay. You see reflection. Does it change? Does my reflection change?
Yeah.
Yes, I have a reflection, so yes.
No, but like if it's like a different
I'm a
kind of mirror.
vampire, so I don't have
Right. So reflection, pretty much, the FL in reflection is a flip. Okay. Again, the size doesn't change. The shape doesn't change. You're just flipping the image. Okay. You're just flipping the image. For example, this is a review. Do you notice here that it has there's a line right here in the middle? What axis is it going from left to right? This is the x-axis, right? X. So this will be called a reflection across the x-axis. Okay? That's how on the STAR test or on future whatever, it'll say reflected across the x-axis, reflected across the y-axis. So essentially, if you just even if you like just take your paper and fold it on that line, you're just flipping that image down. Or if you take a mirror, see the reflection right there? There's my reflection across the x-axis. Right. That's all it is a reflection across. So here, the question is, how far do I move down? If you put dots here on the corners, on the vertices there, how far is this dot away from this axis? 1. So go down 1. You're mirroring. Everything's a mirror. Down all the way down here. This dot all the way down here. So you're going to be drawing the same picture, but just on the other side. Okay. Reflection. That's all that is. Reflection. On the STAR test, the reflections usually are asked like using fractions and decimals. It's the same thing. You just graph the points and just flip them. Okay. Shall we do number 2? Okay, look at number 2. If I draw on the line, Abby, what axis is that? Y to the sky. Y to the sky goes up to the sky. This, they'll say, on a question it might say, across the y-axis. So again, just like what we did with the x-axis, even if you want to fold it and see, you can do that. Or if you put a mirror, imagine a mirror being right there, that image is on the other side. Put dots at the corners, reflect them over. 1 space over, to the edge, to the edge. And you're just drawing the same picture again. Questions about the reflections? Should I go on or no? It's up to you. Okay. Let's do one more. Let's see number 5. Alright, number 5. It tells you the shape is a triangle. It tells you the points. What else? What does this right here mean?
Going across.
But it says x-axis. Which one's the x-axis? This is where the students have the most problem with.
The one that goes like this.
Right. It tells you right there, x-axis. Just draw a line right there. So you tell yourself, hey, make sure the shape is over the x, not over the y. So you're going to graph these points. So first I identify the x-axis, and then I graph these points, +1, +4. That's letter A. 4, 1, B. C is 2, 5. So this makes a kind of a wedge here. So in your head, you should be able to kind of reflect it across the x-axis. Okay. Shift everything down here and here. Reflection across the x-axis. Reflection across the x-axis. Questions, comments? Don't forget you have a quiz on Friday. We have pictures on Wednesday. $25 if you want to buy a picture the next day. Basketball game on Thursday. Bash is Friday. It's a very busy week. Are there concerts coming up? There's a band concert, I know that. Choir, you have a show? I don't know.
Yeah, we do. Wait.
Is it a Christmas show?
Yeah.
Okay. Let me know when it is. What else? Is there any more shows? Is there a recital for dance or anything? I don't know.
Yeah.
December 3rd? Alright. Okay. Do you have the rest of the period? Anything else?
I like shaking.